So this was a lot of fun. I wanted you guys to still be able to get some lab experience. So I created a virtual lab for Chapter 1. It's called Tools for Understanding Matter. You should have that handout with you already. You can pause the video, rewind it, take your time. Once completed, you'll upload it and submit it, and I hope you enjoy it. Identify the 4 pieces of equipment seen here and see if you can read the temperature on this thermometer. Here we're going to add a small amount of sodium chloride or table salt into this beaker with some water in it using a metal scoop. We'll grab our beaker tongs here, pick up our glass beaker. Using the glass stir rod, we're going to stir this mixture up, and then we're going to analyze its composition. So we definitely have a mixture here because we took water and sodium chloride and mixed them together. Now the question is this homogeneous or heterogeneous? In order to know the difference, we'll look closely at how these 2 things mix together. This is salad dressing. It's a mixture. It's separated into layers because it's been sitting for so long. If we shake it, can we get it to mix up thoroughly? That's a question for you to answer. And if it was to sit there, would it settle out again after being mixed? You are to determine if this is a homogeneous or heterogeneous mixture. Here I'm going to use some crucible tongs to pick up this crucible. Inside you can see there's some aluminum and it's shiny. This is a crucible lid. And the other item there is a ceramic triangle used if you were to support this over a Bunsen burner. Volumetric flask, funnel, and wash bottle. I'm going to add a little bit of food coloring to the water in this volumetric flask. And we can just take a second here to observe what happens. Stirring will mix up the diffusion process, and we can ask the question, is the composition of this uniform? The answer to that will help us determine if it's heterogeneous or homogeneous. A volumetric flask is a very accurate device at measuring volumes of a liquid. Add water until you get the bottom of that bubble, which we call a meniscus, to that line. The point at which the bottom of that bubble touches that line, there are 50 milliliters plus or minus 0.10 milliliters. Now, why plus or minus 0.10 milliliters? Well, that's because there's no such thing as a perfect measuring device. In fact, you can see in this example, as I point out, there's a little bit of fluid above the line on both sides. We can't really account for that. There is no perfect measurement, but that's okay as long as we understand how accurate the tool we are using is. And for this particular volumetric flask, it can make accurate measurements within that limit of 0.10 milliliters. It's the reason why it has a skinny neck. That makes it more accurate than, say, a beaker, because the skinnier neck has a smaller meniscus, and therefore you have less unaccounted fluid above the line. Here we have a burette, clamp, and stand. The zero measurement can be found at the top of the burette and 50 milliliters at the bottom. Pause the video here and record this volume. We're going to open up the valve on this burette and watch it drip. Each drop from a burette is approximately 1 milliliter. So we'll pan up here and kind of zoom in to the burette as it drips, and we should be able to watch the level drop about a milliliter each time. We're going to be asked to determine the density of this marble. Density is the ratio between an object's mass and its volume. So the first thing we're going to do is record the mass of this marble. We're going to zero out our balance so that it can ignore the mass of the weigh boat. That's the plastic dish sitting on top of it. Now that it's zeroed, we can put the marble on it, let it settle out, and record that mass on your lab sheet. Water displacement is one way to determine the volume of a spherical object or an object that doesn't have a definite shape. So if we observe the initial volume of water in the graduated cylinder and record that, which you should take a second, pause the video, and determine the initial volume here. Having recorded that initial volume, we can now take the marble, add it to the graduated cylinder. You'll want to put your hand over top of it to keep any from splashing out. And now we have a new volume. The level of the water has increased. How much? The volume of the marble. I'll leave the exercise of determining the density of this marble to you. Let's practice making some measurements a little more. We have here a blue line. It wants us to record the length of that line. And we have a ruler here. At first glance, it looks like the blue line on the paper is 8 centimeters long. Closer look reveals that it's not quite 8 centimeters. What would be your estimate? How many digits could you record it to? Tearing this piece of paper, is it a chemical change or a physical change? Here are some less commonly recognized lab tools. That's a mortar and pedestal. Most commonly, that would be used in a specialty pharmacy in which a particular medicine may be prescribed by the doctor that's not mass-produced in a pharmacy. And so it may have to be mixed, where you take two different medicines and combine them. And one example of that locally here would be Professional Pharmacy. And you can add the solids in here and use the pedestal to crush it up and make it into a fine powder. Here we have 3 items: an evaporating dish, watch glass, and a metal scoop. An evaporating dish can be used when you want to heat something up, maybe to remove the water to dehydrate it. And you can take the watch glass, place it over top of it as it's being heated so that you can still observe what's happening on the inside. How accurate would your pinky fingernail be at measuring? That on average, the width of a pinky fingernail is 1 centimeter. So here we're going to take a ruler and compare mine and see that, well, mine is actually a little bit less. However, could we still use that as a relative standard to measure the length, say, of a piece of chalk? If I had to estimate using my fingernail, it appears that this piece of chalk is pretty close to 2 centimeters. If we now get our ruler and check with it, we can see that, yeah, approximately it was pretty close. I hope you found this virtual lab helpful. You may have to go back and rewatch the video so that you can get the lab handout completed. Sometimes some of the blanks don't always line up with the different stations. You can ad lib, add lines, or you may not use them all depending on which version of the handout you got. Once completed, upload it, submit it, and see you soon.